Went through and preemptively labeled and highlighted some things. So every time I have yellow, it's circled the if or the word assuming. So that gives us our assumption that the lines are parallel. And that becomes really important as we continue to talk about these alternate exterior, alternate interior, corresponding angles, consecutive interior angles. It says, use an informal argument to describe why angle 1 and 8 are equal in measure if lines 1 and 2 are parallel. So we have to go find angle 1, and where's angle 8? Okay, and they appear to be equal, but what would be the reasoning behind it? And so there are a couple ways to look at this argument. I could say that angle 1 and angle 4 are vertical. And if they're vertical, that means that they are congruent. Angle 4 and angle 8 are corresponding. And what that does is it really shows how we kind of combine steps. Angle 1 is congruent to angle 4. Angle 4 is congruent to angle 8. Therefore, with the transitive property, 1 must be equal to 8. A different argument might be angle 1 and angle 5 are corresponding. Angle 5 and angle 8 are vertical. Okay, you might want to pause your video as you're writing this down to go back and color code vertical and corresponding from the previous section. Okay, what this is really proving to us is that alternate exterior angles are congruent when lines are parallel. Okay, and this is another nice result for you. It allows you to shorten up your proof when you start writing them out. Okay, again, assuming lines 1 and 2 are parallel, if the measure of angle 4 is 73 degrees, what's the measure of angle 8? Well, I know that these are corresponding angles, so the measure of angle 4 must equal the measure of angle 8, and the measure of angle 4 is 73 degrees. So 73 degrees must equal the measure of angle 8. How do I know? Corresponding angles are equal when lines are parallel. So the assumption that lines being parallel becomes really, really important. Going on to number 5, assuming lines 1 and 2 are parallel, the measure of angle 3 is 107 degrees. What is the measure of angle 6? Well, if I go up to my diagram, I look at angle 3 and angle 6, I understand that they're alternate interior angles. So the measure of angle 3 must equal the measure of angle 6. The measure of angle 3 is 107 degrees, so the measure of angle 6 must also be 107 degrees. Why? Alternate interior angles are equal when lines are parallel. Okay, we have just a few more. The diagram is no longer in your picture, but we can use the one that's on your page written down to help us. Next, it says, assuming that lines 1 and 2 are parallel, if the measure of angle 2 is 107, what is the measure of angle, or what is the measure of angle 7? Now we can use the result we just figured out that these are alternate exterior. The reason why I know that is because they're outside of the parallel lines and they're on alternate sides of the transversal. So the measure of angle 2 must equal the measure of angle 7. 2 is 107 degrees. The measure of angle 7 must also be 107 degrees. Alternate exterior angles are equal when lines are parallel. Okay. Next, and I changed the way I highlighted this because no longer am I assuming the lines are parallel, but I'm assuming that they are not parallel. What happens in that situation? Well, it completely changes things. If lines are not parallel, corresponding angles and alternate interior angles are not equal. So it completely changes the landscape of our problem solving. Use an informal argument to describe why 1 and 5, notice I highlighted them in blue because their corresponding angles are equal in measure. We'll get more into this formality next unit where we talk about transformations, but essentially what I can do is, again, cut between the two parallel lines, and I can translate down 1 on top of 5, and translations preserve measure, and therefore 1 and 5 will be exactly the same. Translations preserve measure. So when we translate 1 onto angle 5, measures will be equal. Okay, and again, we'll get into that more formally in the next unit. But right now, you know that certain transformations have rigid motion, which means nothing changes about them. This also helps us with number 9. So number 9 says 4 and 5. So I look at this. Basically what I can do is I can rotate 4 180 degrees and it'll lie right on 1. And then 1 translates down onto 5. So it's a combination of two rotations and translations. Preserve measure. Therefore, after rotating angle 4 and then translating onto angle 5, measures are equal. So again, this only works if you have parallel lines. Finally, we assume that lines 1 and 2 are not parallel. Explain why angle 3 and angle 7 are not equal. So corresponding angles are equal only if lines are parallel. The three little dots mean therefore in geometry, therefore angle 3 does not equal angle 7. The converse is also true. If angle 3 does not equal angle 7, lines cannot be parallel. So it kind of works in both directions. Okay, so pause, highlight the vocabulary. Have a nice day.